Okay, now in section 3, there are 6 integer type questions. So let's see the question number 8. A person sitting inside an elevator performs a weighing experiment with an object of mass 50 kg. Suppose that the variation of the height of the elevator from the ground with time t is given by y equal to 8 into 1 plus sine of 2 pi t by capital T, where capital T is 40 pi second. Taking acceleration due to gravity g equal to 10 meter per second square, maximum variation of object's weight in Newton as observed in the experiment is. So let's say this is one elevator. Inside, one mass is there, that is 50 kg. Now gravity is acting downward. Now this lift height is varying continuously as per this function, that is 1 plus sine of 2 pi t by capital T. Capital T is the time period. We'll just put the time 40 pi second. We'll just put it here only. 1 plus sine of 2 pi t by 40 pi, that is t by 20. Why? Now the weight of the mass is m into g, but there will be another component of weight due to the variation of the height of the lift, that is y double dot. So we can directly write m y double dot, because the height of the lift is continuously varying, and due to that one more acceleration component is getting generated, that is y double dot. So pseudo force because of that acceleration is my double dot. So weight will be mg plus my double dot. Mg we can write mg right now plus my double dot. What is y double dot? We can find out. Y dot is 8 into cos t by 20 interthing by 1 by 20. Y double dot is 8 minus sine t by 20 interthing multiplied with again 1 by 20, so 1 by 20 square. So it is becoming 8 by 20 square minus of sine t by 20. So weight I can write, that is mg minus m into 8 by 20 square sine t by 20. So m and g value I'll put, that is 500 minus 50 into 8 by 20 square sine t by 20. So 500 minus, this is 400 by 400, so 1, so sine t by 20. That is the weight of the body. So see, weight of the body is varying with respect to, this is the mean weight, it is varying both sides. So maximum value of the weight, that is becoming when the value of sine t by 20 is minus 1. So maximum weight is becoming 501 Newton. Minimum weight when the value of sine t by 20 will become 1. That time the minimum weight will be 499 Newton. So what is the maximum variation of the weight? See, if I plot the weight with time, this is the mean value and the weight is varying like this. So with respect to the mean value, that is the 500 Newton, it is varying on both sides. Upward also it is varying by 1, downward also is varying by 1. So the maximum variation from the minimum point to the maximum point is 2 Newton. So 501 minus 499, that is 2 Newton is the maximum variation of weight. So our answer is 2. Question number 9. A cube of unit volume contains 35 into 10 to the power 7 photons of frequency 10 to the power 15 hertz. If the energy of all the photons is viewed as the average energy being contained in electromagnetic waves within the same volume, then the amplitude of the magnetic field is alpha into 10 to the power minus 9 Tesla. Taking permeability of this, okay, the value of alpha is the number of photons that is contained in unit volume, that is given already 35 into 10 to the power 7, and each of it is having frequency of 10 to the power 15 hertz. So total energy of all these photons will be n into h nu, where n is the number of photons, 35 into 10 to the power 7. H is the Planck's constant, that is already given 6 into 10 to the power minus 34, and frequency is given 10 to the power 15. So if we just multiply 210 into 10 to the power minus 12 joule. Now magnetic field energy per unit volume is p square by 2 mu, that should be equal to the total energy of the photons, that is 210 into 10 to the power minus 12. So we can just put the value of mu, and we will be able to find out what is the value of p square. P square is 2 into mu naught is 4 pi into 10 to the power minus 7 into 210 into 10 to the power minus 12. So 2 into 4 into 22 by 7 into 10 to the power minus 7 into 210 into 10 to the power minus 12. So 730, 240 into 22 into 10 to the power minus 19. That is the value of B square. So B, we can find out that that is 22.9 into 10 to the power minus 9. So in our question, it is given as alpha. So alpha value will be 22.9. That is our answer. So next question is question number 10. Two identical plates P and Q radiating as perfect black bodies are kept in vacuum at constant absolute temperature Tp and Tq respectively, with Tq less than Tp. So that means the radiational energy is going from P to Q like this. And the value is given as W naught. Subsequently, two more plates identical to P and Q are introduced between P and Q. Assume that the heat transfer takes place only between adjacent plates. If the power transferred per unit area in the direction from P to Q in the steady state is Ws, then the ratio W naught by Ws is. See, it is a problem of radiation shield. Now let us say two plates are there. There is nothing in between. Temperature is Tp, here temperature is Tq. So the net radiational heat transfer W naught, that will be sigma of Tp to the power 4 minus Tq to the power 4. Pi will consider that some radiational resistance is there, that is R, radiational resistance, or R suffix R, radiational resistance. So whenever I am introducing two more plates, I am just adding the resistance or I am increasing the resistance. So we'll consider that this is plate number 1, this is plate number 2, and this is plate P, plate Q. So from plate P, the heat Ws, or the radiational heat transfer rate, that is Ws, is going to 1, then again from 1 to 2, then again from 2 to Q. So 3-step process. So first we'll consider the radiation heat transfer from plate P to plate 1. So sigma Tp to the power 4 minus, let us say the temperature of plate 1 is T1. So we'll consider T1 to the power 4. Pi, let's say the resistance is R, suffix R. That is equal to sigma of T1 to the power 4 minus T2 to the power 4. Pi, radiational resistance is RR because they are similar plates. They are all having the same surface properties. And finally from 2 to Q. So 2 T2 to the power 4 minus TQ to the power 4 by R. Now, if we add the numerators and we add the denominators, ultimately, if we add this and this, ultimately we'll get sigma TP to the power 4 minus TQ to the power 4, and in the denominator we'll get 3R suffix R. Now, this is the radiational heat transfer when the radiation shield is introduced. So that is WS. WS is becoming sigma Tp to the power 4 minus Tq to the power 4 by 3R suffix R. But we already got the value of this one to be W naught, so WS. So what is the value of W naught by WS? 3. So answer is 3. Now question number 11 we'll see. Actually this problem requires a lot of drawing. So I'll try my best to draw. A solid glass sphere of refractive index n equal to root 3 and radius capital R contains a spherical air cavity of radius R by 2 as shown in the figure. So this is the air cavity, and this is the glass which is gray color. An unpolarized unidirectional and monochromatic light source S emits a light ray from a point inside the glass sphere towards the periphery of the glass sphere. If the light is reflected from point O, final light will get reflected from here and it is fully polarized, then the angle of incidence at the inner surface of the glass sphere is theta, the value of sine theta. That means this angle we need to find out. So for that we need to draw in a big scale. We'll draw. This is the glass sphere. This is the center of the glass sphere, and there is one cavity of air inside the glass sphere. Okay, perfect. The refractive index of glass is root 3, and for air it is 1. This is air. So the final ray that is getting reflected at this point it is getting reflected. So that maybe the ray will be coming like this. This is a point where there is some density change. So here the refraction would happen, and while the light was coming from here all the way from here, ultimately at this point when it will try to enter the air cavity, that time the light ray would go from the denser medium to the rarer medium. So that means at that point it will bend away from the normal. So what is the normal? Normal is the center of the air cavity will just join with the point of entering. It will bend away from the normal. That means, and if we extend it, it is our normal at that particular point. So maybe this is how the light ray would come. After getting reflected from the glass surface, here at the interface, it would come like this. So this is the angle of refraction. This is the angle of incidence for the air cavity. Now here, what is the normal? I have to join the actual glass center with that particular point, and that will be our normal at this point. So that means after the reflection, it is looking like this. So before the reflection, how it was looking? Maybe like this. And here was the light source. Let's say. So again, I will join with the center so that I can make the normal all the time. So this is our light source was emitting light initially. This is our angle theta. Similarly, the reflection angle also theta. This is also theta. And this is also theta. Now, it is given that the light will be polarized after getting reflected from point O. What is the condition to be polarized? At this O, what is the angle of incidence? This is the angle of incidence. So angle of incidence at that point should be equal to tan inverse of the refractive index here. What is the refractive index here? Root 3. So I will be tan inverse of root 3 or 60 degree in order to get polarized. So here I we found out that is 60 degree. If this is 60 degree, this angle is also 60 degree. So at this interface where light is entering the air cavity, that interface, the refraction angle or the angle of refraction is 60 degree, right? This becomes 60 degree angle. So at this interface, if we apply Snell's law, so light is entering from glass that is having refractive index of root 3 into angle of incidence in that medium, let's say sin I dash is equal to 1 into sine 60 degree. So I dash, sine of I dash, I am getting root 3 by 2. Here root 3 is there, so half. So I dash, I am getting 30 degree. So angle of incidence at the interface of the air cavity is 30 degree. So this is 30 degree angle. Now I have to find out the angle theta. I have got some values. Now I'll find out the angle theta. Now see, if I join this and this one, this is 60 degree, this is 60 degree, this is also 60 degree. So this angle is becoming our 120 degree angle. And if I join this center and point of entering the air cavity, if we join this line, ultimately I am able to make two triangles. One is this triangle, another is this triangle. I am just putting arrow. So from the first triangle, this triangle will consider. So this triangle will consider. This triangle, see, this is r by 2, this is r by 2, this I do not know, this length. Let us consider this length to be L. So L by sine 120 opposite angle is equal to r by 2 by, this is 30 degree, r by 2 by sine 30 degree. So we'll be able to get the value of L. L I am getting r by 2 sine 30 into sine 120, that is root 3 by 2. So ultimately I am getting the value of L to be root 3 by 2 into R. Now if I get the value of L, how we are going to use it? We are going to use it in the second triangle, this triangle. This triangle, L by opposite angle, that is sine theta, is going to be, this is R. R by its opposite angle is this one, this one. This is 30, this is 30, so this is 120, sine 120. So L I have already got, that is root 3r by 2 sine theta. I am getting ultimately r by root 3 by 2. So the value of sine theta I am getting from here, I am getting value of sine theta to be root 3 by 2 into root 3 by 2, that is 3 by 4. And that is our answer. That is 3 by 4 or 0.75 is our answer. Well, the next problem actually error analysis problem, but it is given in the frame of diffraction. So let's see the problem. A single slit diffraction experiment is performed to determine the slit width using the equation BD by D is equal to m lambda, where B is the slit width, D is the shortest distance between the slit and the screen, D is the distance between the mth diffraction maximum and the central maximum, lambda is the wavelength, capital D and small d are measured with the scales of least count 1 centimeter and 1 mm. So for D, the scales are having least count of 1 centimeter. For small d, the scale is having the least count of 1 mm. The value of lambda and m are known precisely to be 600 Newton meter and 3 respectively. The absolute error in the value of b estimated using the diffraction maximum that occurs for m equal to 3 with d equal to 5 and d equal to 1 meter is. So see, BD, the formula is already given. BD by capital D is M. Now I have to find out the absolute error in the value of B. So B I will express in other terms, other variable terms. M lambda capital D by small d. I'm just jumping one step. That is delta B by B will be delta M by M, of course plus minus, plus delta lambda by lambda plus delta d by d plus delta small d by d. Now, so these are constant terms. We'll just make it 0. But the error in d, there is a least count. It is given 1 centimeter. So 1 centimeter and d is given 1 meter, right? So 1 centimeter I will just express in 1 meter. That is 10 to the power minus 2. There is a error part of d. It is delta d. It is 1 centimeter because there is a least count of the scale by 1 plus least count of d, that is delta d, is 1 that is 1 by d I am measuring, that is 5. It is 5. So what is that? So ultimately I am getting 10 to the power minus 2 plus 0.2, that is ultimately I am getting 0.21, that is the relative error in B. So what is the absolute error in B? Delta B, B into 0.21. Now what is B? From the formula I can put the value of B, m lambda capital D by small d, m lambda capital D by small d into 0.21. So m value is given as 3, lambda value is given as 600 Newton meter. So we'll express in micrometer because the answer is asking the micrometer, into capital D is 1 and small d is 5 small d is 5 so 5 into 10 to the power minus 3 into 0.21. So ultimately this is getting cancelled. So 5 120, I'm getting 360 into 0.21 micrometer, that is 75.6 micrometer, and that is our answer. Our answer should be 75.6. Let us see question number 13. Consider an electron in n equal to 3 orbit of a hydrogen-like atom with atomic number Z. At absolute temperature T, a neutron having thermal energy Kb into T has the same de Broglie wavelength as that of this electron. If this temperature is given by T equal to this expression, where A0 is the first Bohr radius of hydrogen atom and the Mn is the mass of the neutron, then the value of alpha we have to find out. So first we'll consider that this is a nucleus. Let's say the nucleus is having charge of Z into E and one electron is there at some distance r. It is rotating keeping this radius with velocity v, and if the mass of the electron is m, then we can write that mv square by r, that is the force, that is the centrifugal force, that will be balanced by the electrostatic force towards the center, that is 1 by 4 pi epsilon naught Ze into E by r square. So we can equate these two. So we'll get that m v square by r is equal to 1 by 4 pi epsilon naught into Ze into E by r square. Upon simplification, we'll get mv square into r, that is Z into E square by 4 pi epsilon naught. That is equation number 1. Now second equation will get, that is mvr, that is the angular momentum of the electron, that will be equal to n into h by 2 pi. That is equation number 2. So from these two equation, if we divide equation number 1 by equation number 2, we'll be ultimately able to eliminate r and we'll get v, expression of v. 1 divided by 2, we'll get the expression of v. V is z into e square by 4 pi epsilon naught divided by nh by 2 pi. So upon simplification, we'll get z e square by 2 n h epsilon naught, that is the expression of v, or the velocity. Now it is given that the de Broglie wavelength of the neutron will be same as that of the electron. So what is the de Broglie wavelength? H by mv. So for neutron also the same de Broglie wavelength will be there, mn vn. So see, h by mn vn, that is the momentum, we can directly write that is 2 of m k, where k is the energy of the neutron and that energy is given as kb into t. So we can directly put power of 2m n, that is the neutron, sorry, n will be there, neutron mass into kb into t. That will be equal to the same of the electron de Broglie wavelength, that is h by mv. From here we can write 2 mn kb into t will be equal to mv square. So m square into v square will do. V square, v expression we have already got, that is z square e to the power 4 by 4 n square h square epsilon naught square, that is our 2 m n kb into t. So see, we are getting ultimately one expression for the temperature T, that is m square z square e to the power 4 by 8 n square h square mn kb epsilon naught square. But in our expression there is something called a naught, where a naught is the first Bohr radius of hydrogen atom. So from equation number 1 and 2, we have to find out what is the first Bohr radius r. So we have to eliminate v from here and we will be able to find out what is the value of r. So from equation 1 and 2, I have to eliminate v in order to get the expression for r, and I have to put n equal to 1 in order to get the first Bohr orbit radius. So if I do 1 by 2 square, ultimately we'll be able to eliminate v. So if we do 1 by 2 square, then ultimately I'm getting mv square r by mvr square is equal to z square by 4 pi epsilon naught by nh by 2 pi square. So here I am getting in the left hand side 1 by mr, that is equal to z square by n square h square epsilon naught, and there is 1 pi. So if I put the value of n to be 1, that is the first Bohr orbit radius, we'll be able to get that time r will be equal to a naught. So 1 by m a naught, that will be equal to z square pi by h square epsilon naught. So the value of a naught we are getting, that is epsilon naught h square by m z square pi. So a naught square that we are getting h to the power 4 by m square z square to the power 4 pi square. A square value we are getting this one. So if we put here, ultimately we'll ultimately get this expression. I am not doing that right now. So z square h square by z square h square by something 8n square into n naught square, and other terms will be there. So see, in the question n equal to 3, consider the electron in the n equal to 3 orbit of a hydrogen like atom. So in this expression I have to put the value of n equal to 3. So whatever expression is there, numerator denominator, 8 into 3 square will get ultimately, if we put n equal to 3, so ultimately we are getting 1 by 72 numerator denominator. So the value of alpha will get ultimately be 72, and that is the answer.